All right, hopefully this problem is a little friendlier than the last one. This problem 4 is from 2010, it's question number 5. So a large pet store buys the identical species of adult tropical fish from 2 different suppliers, Buy Right Pets and Fish Friends. Several of the managers at the pet store suspect that the lengths of the fish from the Fish Friends are consistently greater than the lengths of the fish from Buy Right Pets. Random samples of 8 adult fish from the species at Buy Right and 10 adult fish of the same species from Fish Friends were selected, and the lengths of the fish in inches were recorded. All right, so we have 2 random samples. They're two separate places, so these are going to be 2 independent random samples. That's a good place to start. Do the data provide convincing evidence that the mean length of the adult fish of the species from Fish Friends is greater than the mean length of the adult fish of the same species from Buy Right Pets? All right, so because they're using a direction on this, I would highly recommend that you do a hypothesis test. It's more difficult. It could be done with a confidence interval, but substantially more challenging. And they use the word mean. So that means when I see that word, I go, all right, I'm either going to be working with a Z or a T, but what they gave me is a standard deviation from the sample. And because the standard deviation is from the sample, then I know I'm working with a T, so I'm not working with a Z. I can only work with a Z when I know the standard deviation of the population. I don't know that. So I'm working with standard deviation of sample. So working with a T, I have 2 samples, so this is going to be a 2-sample T-test. My null hypothesis is if there's no difference, that they are equal. And my alternative, depending on how you defined it, mean length of fish from Buy Right is less than the mean length of fish from Fish Friends. If you swap the order, then you're going to swap your inequality, and that's fine. I did mine based on Buy Right is less than Fish Friends. You could have done it on Fish Friends is greater than Buy Right. Just make sure that you're consistent throughout the problem, whichever you choose. Condition, both fish samples are independent random samples. That's given. We're given 2 independent random samples. I need to check the N is less than 10%. You will not see that in the scoring guideline, but over the past 2 years, this has become an important thing. Fortunately, I've always taught it that way, but they're now looking for this, so make sure you always do this. And once again, this is to make sure that your sample size, do your sample selection because you're sampling without replacement doesn't have an impact on the population percentages. Again, the giant pile of M&Ms, you take one out, it doesn't substantially impact things. So we had 8 from Buy Right, 8 times 10 is 80, or what I typically had done, and I don't want to confuse people, I just said 8 divided by 0.1 is 80. And hey, we know that there are probably at least 80 fish from Buy Right. So reasonable to assume that. And it's also reasonable to assume that 10 divided by 0.1 or 100 fish come from Fish Friends. So, because we would suspect that they're buying many more fish than that. All right, so now I need to check for normality. Unfortunately, they did not tell me the data was normal. Unfortunately, my sample size isn't greater than 30. So since that's not the case, I need to check for any reason why it's not normal, which means I input this information in the L1 and this information in the L2, and I'm going to go ahead and graph it, but I'm going to show you stat edit. So there's my information. It's included in both of those. All right, and I go to second stat plot. I made sure my first stat plot is on. It's highlighted and on. I went over and selected the one with showing outliers. Then I press second one. All right, I now have my first stat plot done. I'm going to go to my second one, highlight plot 2, make sure it's on, go through the same procedure, but now I need to make sure that my X list is L2 for Fish Friends. And then I'm going to press zoom 9. And there are my 2 box plots. When I look at those 2 box plots, I go, you know what? First off, I don't see any outliers. I also look at them and go, you know what? This is very, very symmetric. This one isn't as symmetric. but it's not too bad. In the grand scheme of things, that's not bad. And I can look at this distance and this distance, and they're about the same. So neither sample has outliers, nor show extreme skewness. I like this phrase because if you see skewness, you can say that that's not extreme. Okay to assume that both underlying distributions are reasonably normal or approximately normal. So then I write down my formula, and this is for sample 1, Bi-Rite, Fish Friends, their standard deviation for each one. I plugged in, and by the way, I could have used the data, but in the event that I made a in the event that I input it incorrectly, I'm choosing to use what they gave me. So they gave me the X bar for Bi-Rite, they gave me the X bar for Fish Friends, and that's what I'm going to use to plug in as opposed to the actual data, although the calculator would permit you to use the data. So when I do that, I'm going to go stat test, and we're working with a 2 sample, and we said it was a t-test because we're using the standard deviation of the sample. The mean of Bi-Rite was 3.4 with a standard deviation of 0.434, and our sample size was 8. The sample mean for Fish Friends was 3.46 with a sample standard deviation of 0.55, and our sample size was 10. That was the direction of my alternative hypothesis, so I need to make sure that I match that direction. We never pool when we're working with means. I go ahead and calculate this, and I end up getting a t-statistic of negative 2.586. All right, this should have been a negative sign right there. I don't know why it's not there. All right, so we end up getting a t-statistic of negative 2.586, and that's about 40% of the time, or 0.3996. That's a pretty large p-value. Matter of fact, it's greater than any reasonable alpha, so since it's greater than 0.05, we're going to fail to reject. So the p-value is 0.3996. Given alpha of 0.05, we fail to reject a no. There's no sufficient evidence that alpha equals 0.05 to suggest that the mean length of fish from Bi-Rites is less than the mean length of fish from Fish Friends. Simplified wording. Try to include these. We cannot say that Fish Friends mean length is greater than Bi-Rite. All right. Okay. One other comment I want to make. This is not necessary for this problem, but please note we didn't prove the null. We didn't prove that they were equal. We just couldn't prove that that Fish Friends were bigger or that Bi-Rite was less. So we never proved the null. We never proved the null. We just sit there and go, hey, you know what? We can't reject it. All right. And in this case, since we failed to reject, if we made an error, and we don't have any reason to believe we did, because if we did, we'd fix it. But since it's failed to, the only type of error could have been a type 2. So the only type of error that we could have even been remotely accused of doing is a type 2, but we have no reason to believe that we did. All right.